I'm going to introduce you now to Vlad, Vinogradsky, who is the product leader for Azure API management at Microsoft, and he's going to be telling you all about the updates on API management. So over to you, Vlad. Thank you.
Thank you, Duncan. So we have a very simple agenda today. I'm going to start by telling you about stuff we've recently done and things you may already use. Then I'm going to talk about some of the things that we are working on, and I'm going to show you a demo at the end. It's kind of pre-release beats, a lot of moving parts, so it will be very exciting for me. But if it works, it will probably be exciting for you as well. Quick show of hands. How many of you guys have a basic understanding of API management? This is fantastic, because I don't have an overview except this one slide. So just to catch up a few of you who don't know, Azure API Management service in Azure is used by API providers to expose the APIs to app developers. It consists of three things: a gateway, a management plane with a configuration database, and developer portal. API providers interact with the management plane and the API management service through a number of interfaces. Obviously, Azure Portal, but also PowerShell, ARM templates, REST API, and of course, SDKs and things like that. App developers, interact with the product through developer portal. That's where they can discover APIs that you published, on board to use them, learn about how to use them, get some assets to get started, interact with the API without writing a line of code. Gateway mediates communication between apps and backend APIs. It basically serves as a facade, allowing you as an API provider flexibility to change the architecture of your backends without impacting your clients. It also becomes basically a front door for all of your API traffic, and thus becomes a very good place where you can do routing, do monitoring, do protection and security, and things like that. API management is very well obviously integrated with the rest of Azure services. For example, for observability, we have integration with App Insights and Azure Monitor for login tracing, troubleshooting. We have integration with networking stack on Azure, specifically App Gateway for Web Application Firewall, for example. Virtual networking for private backends, as well as reaching back to on-prem. We have integration with Azure AD, as well as with event hubs for custom analytics and essentially generally asynchronously extracting data from the gateway. And we support a multitude, essentially all of the compute services on Azure that are used to build APIs as well. So that's kind of a quick introduction, right? If you remember three things about API management, it's about facade, front door, and frictionless consumption of APIs by your app developers. With that, we're going to move on to stuff we recently released. That is like vegetables is good for you. And you might have missed it because it's hard to keep track of all these services. So I'm going to start with policies. Policies are essentially encapsulations of API management functionality that you can configure at different scopes in API management, for instance, for a single API or an API operation for all APIs. And they essentially can be configured with parameters, including dynamic parameters through expressions. And they kind of enforce, the policy. A gateway enforces the policies you set. So we have a policy for JOT token validation for Auth and OpenID Connect. We added support for encrypted tokens. So as you can see, we added a new element there, decryption keys. It's very similar in a sense to issuer signing keys, and you can specify your keys for encryption there. It can be more than one. It's exactly the same format as for signing keys, so the policy essentially works as it is, but now it has extended capability. Now, there may be some advanced scenarios where you actually want to get the token itself and do some additional advanced authorization on top of it. So for that, we added actually a new variable, a new attribute, output token variable name, where essentially you can sort of assign a name for a variable to receive the token upon successful validation of that token. So you can be sure that if policy didn't throw in error, there's actually a token sitting in that variable. And then you can obviously use that variable, like example here, to do some advanced validations as well. So again, you can do sort of simple validations and advanced validation to get this unencrypted token out. Managed identity. How many of you guys heard of managed identity on Azure? Excellent. Managed identity is a very good way to authorize services, authenticate unauthorized services to each other on Azure. So we added support for managed identity. So now you can enable managed identity as shown on the left for your service. And then we provided a policy with which you can authenticate against the backend using that managed identity. There is a step of creating an app in Azure AD tenant for that particular resource on the back. But of course, it's not shown here. But if you do that, you can actually use that to authenticate requests from API management to your backend. The only attribute that is mandatory is a resource, which basically indicates the name of the resource. And then the other two attributes are optional. One of them, sorry about that. One of them, output token variable name, obviously received the token the same pattern as in JWE. And then ignore error tells it basically to not throw if validation is if it can't acquire a token. What this policy essentially does, it goes to AD, authenticates with managed identity, gets a token for a resource indicated in resource attribute, and then stuffs that token into authorization header. So it does all of that on your behalf, right? So it's a very terse little policy. But if you want to submit that token in a different header, for example, that's where output variable comes into play. You can get it there, and then use set header policy to set it to any other header, for example. Protocol settings. So we introduced that a little while ago. So this allows you to configure security aspects of your TLS connections. By default, we always enable the latest TLS protocol, but you can optionally enable the down-level protocols if you have backends or clients that require that, and you can actually configure them differently, set them differently on both client side and backend side. In addition to that, recently we added support for HTTP2. As you can see, it is on the client side of the gateway for now, so we call it downstream side. But we're going to extend it, obviously, to the other side as well. Response caching is a great way to improve perceived latency for your applications by essentially bringing these APIs closer to them, as well as offload your backends, right? Because when the request is served from cache, it doesn't go to your backend, and could be good for some of the legacy backends that maybe not necessarily were designed with internet scale in mind. So we always, from the beginning, supported built-in cache, which each of the tiers of API management comes with a certain amount of cache, and you can scale it by adding units, and that works really well. But now we added also ability to bring an external cache that you can configure. It has to be Redis compatible, so you can use Azure Redis cache, you can use cache from Redis, you can use VMs and host Redis itself. All we care about is Redis compatible. You need to give us a connection string. As you can see, you can sort of specify from which API management region that particular cache needs to be used. So if you have premium with multiple regions, you can configure different caches for different regions, for instance. And essentially, the policies remain unchanged. So again, your policies will continue to work as expected. The only thing we did is we added a new attribute, which is optional, and it has 3 values, and it sets cache preference. And as with any policy, you can set it at multiple scopes. So essentially, you can configure different scopes, different APIs, different operations to use different caches, external versus internal. And that attribute allows you to sort of control that. But if you don't touch it, if you don't have it set in your policy, it will work as expected. Subscriptions, to remind you all, subscriptions essentially are named objects that contain keys, 2 keys, so you can do rotation. Essentially before, each of these subscriptions had to be associated with an owner, a user, and was scoped to a product. So we extended this model a little bit. First of all, we created actually a special blade for it, so you can find all your subscriptions in one place, be it active as well as pending. Now you can actually define API and all APIs scope for a subscription. So you can actually create a subscription or key that unlocks all APIs, a single API, as well as an API is included in the product. Moreover, you don't have to have actually an owner, a user associated with the key. So if you want to just create a key as basically a standalone key for a certain app or a service in your organization, you can do that. You don't have to have a user. So now essentially, if you want to get access to API, you don't have to create a product. You don't need to have a user. You just create a key for whatever scope you want and start using it. Moreover, we now actually show which keys support tracing, and you can enable tracing on any key you want, right? By default, only admin subscriptions get tracing enabled because tracing can reveal secrets and sensitive information about your APIs, but you can set it if you wish. Lastly, we automatically create a built-in subscription that is there out of the box, and it improves sort of the usability of the console. And essentially, it's a key that unlocks everything. Think of it as a master key for all your APIs. Again, out of the box, you can use it. Everything works. As an admin, you can use it to test things and stuff. Observability. So we had, Azure Monitor support. We added application size supports a year ago, but now we added actually a lot of configurability about this. For integration with those technologies. As you can see, it's very symmetric. You can configure the same options for Azure Monitor and App Insights. You can disable those for the whole tenant or for specific APIs and have different settings for different APIs. As you can see, you can conserve resources by turning on sampling while still getting all the errors logged, right, which you probably want. You can also specify additional headers to log. By default, we log almost no headers. You can also specify up to 1K of bytes from your content to be logged. And more importantly, you can set all these properties for 4 sort of taps on your gateway, on both sides of the inbound and on both sides of the outbound, right? So you can collect a lot of information and see how things change using these policies. So with that, we have very, very nice and efficient the support for both sort of observability solutions that we have on Azure, and you can tailor them to your specific requirements. Functions. We actually improved our integration with functions in 2 ways. So first of all, the import process from API management, where you can sort of grab a function app and create an API for it in API management, allows you to select specific operations you want to expose. You don't have to actually expose all functions, right, within the function app, only specific ones that you want. More interestingly, potentially, is ability now to associate an API management instance with your function app and push functions as API endpoints into API management from the function user experience. And that shows on the right, that's the experience there, right? And essentially, when you do that, it brings up our blade within the function blade, which works really well. In fact, we actually like functions so much that we created a whole consumption tier that works great with functions. It's right there on the bottom in green. And you probably noted that there is no preview label anymore. It was GA last week. So what is this consumption tier? Consumption tier, essentially think of it as an API management gateway, which is serverless. By that I mean that there's no reserved capacity. Resources are provisioned when there is traffic, and then it scales down to 0 when there is no traffic. There is per execution or per call charge, right? So it's purely based on usage. It's automatically scaled. It's HA, highly available out of the box, so you don't have to worry about it. So it's a very nice solution for a primary use case of essentially exposing your serverless endpoints, functions, logic apps, and others as APIs. It has some feature limited feature limitations and usage limits stemming from the architecture. It's a multi-tenant architecture. In fact, it's a very different architecture from the previous tiers that we had, right? So we had, it took also almost a year to get it out in GA. It was significant sort of rework on the back. We used the same components, that they architected completely differently. So it's an awesome tier that we hope to see a lot of growth in, and it's already been used in preview by thousands of customers, and many of them are making tens of millions of calls per month. So it's pretty robust, and so I encourage you guys to try it if you didn't. Lastly, but not least, we released an open source DevOps resource toolkit, which solves the problem for customers of automation deployment into an API management instance shared by multiple teams. So obviously the problem is, how do you not step on each other? How do you make sure that everything works correctly? What are the best practices? And so we created sort of that guidance as well as a set of tools that Meow will tell and show you all tomorrow in his session. And with that, we're moving on to the future stuff. So we've been working on a new developer portal for about 6 months. And this is all I'm going to say to you about that. Mike will have a session tomorrow. He's sitting right there and just giving me an eye. So he expressly forbid me to mention anything about that. So you'll have to wait until tomorrow morning to be amazed. And you will be amazed. Now, here's something I'm going to tell about. So as you probably know, up until now, API management was a cloud-only service, which means that essentially all the components of API management were deployed in the cloud. That works really well for APIs that are based in the cloud, right? Like shown on this picture. However, we know that 80 to 90% of our enterprise customers actually have both on-prem APIs and potentially use other clouds. So you may have actually APIs there. Well, we have actually a pretty good story for APIs on-prem, right? It's using virtual networking, you can reach there. You can do similar things with other clouds. So it kind of works. Things get a lot worse when you have actually clients that consume those APIs from those environments, right? Because what happens in this case, you have to actually go through the cloud and all the way back to that environment, which obviously is not efficient, and in some cases actually impossible due to some regulatory constraints that customers may have or security sensitivity. So those kind of use cases were not really supported by API management. And customers had to, usually what they would do, they would employ different solutions in different environments. They'll use Azure API management for the cloud. They'll have some solution on-prem, and then they use other vendor solution in a different cloud. And that obviously, as you can imagine, expensive, right? And it's operationally expensive as well, because you have to have now people who are proficient in 3 different API management solutions, which are incompatible. You don't have a single view of all of your APIs. It costs you a lot of money, a lot of time, and a lot of effort. Now, we can probably solve this problem better, obviously, by making gateway component deployable in your own environment. So you can essentially deploy it on-prem, in other clouds. These gateways can connect to the cloud to get essentially configuration and pushback telemetry. And then situation actually becomes much more efficient. So not only the calls can go directly to those environments, right, not go through the cloud, but when these APIs are called from within the environments the APIs are in, these are direct calls, right? So it works really well. And now, with a single API management solution, you can manage APIs anywhere, right? So you don't need multiple solutions. You can have just proficiency in API management and have all the information about all your APIs in one place, including telemetry if you wish. So that's something that we've been working on, and we call it self-hosted API, I forgot to say federated API management gateway. So it's a bit of a, we didn't come up with a good name for it yet, but the essence of it is essentially it's a self-hosted, meaning that you host it yourself. Federated means that it actually federates with API management instance in the cloud. That's a prerequisite. and it's a gateway component, right? So it will be packaged as a Docker container for Linux. And it will be functionally equivalent to our managed gateway in the cloud. When I say functionally, it's sort of a temporary thing, right? So because we had to make some changes to, first of all, run it on Linux, plus we're doing some other work to optimize it further. So when we're done with it, we essentially will start using that not containerized, but that exactly the same code, modular packaging in the cloud as well. And then it will be basically the same code, not just functionally equivalent, but the same gateway that we use in the cloud. So as I mentioned, they have to rely on API management service for configuration and optionally to collect telemetry. Again, you want to see all your stats, all your metrics, all your logs in one place. That would be your API management instance. And we will recommend that you host it in Kubernetes because it seems like Kubernetes is the most popular solution for orchestrating containers. But of course, it's a Docker container, so you can actually host it anywhere. There's many solutions that support that, including you can run it on your desktop, essentially, right, as a single instance. Obviously, not recommended in production. So I'm really happy to announce that we've been talking about this approach forever, but now we're actually building it. And we should be available, and we should have a preview available for you guys sometime this summer, hopefully. And now I'm going to show you some demo, which is very exciting. I've got Docker, and I've got Minikube, right? Minikube is a very efficient way to host Kubernetes on your machine. So it's all running here locally. In my Docker, I run a container. This is essentially HTTP bin, right? httpbin.org. You can go check it out. If you haven't seen it, I can show you. So as I said, it's running on my machine. So if I go to localhost, here's HTTP bin, right? Running in the container on Docker on my machine. And it has a bunch of different methods for debugging, and you can basically call it and see that it works. Right? So you get a response. So that's my backend, right? That backend runs in the local environment, which is my machine here. I also run Kubernetes, right, in Minikube. And as you can see right now, the only thing that I have, right, is the Kubernetes itself. So, the basically, system components of Kubernetes. There's nothing else here. So now what I'm going to do is I'm going to install this self-hosted federated API management gateway here in this Kubernetes environment and make it proxy calls to this containerized HTTP bin API running on my machine under Docker, right? So not on Kubernetes, on Docker. So I will use Kubernetes solely for the purposes of hosting my, my gateway. So to do that, I'm going to go to my instance in the cloud. It is, as I said, updated with pre-release bits. Oi, oi, oi. Let's do it again. Let's try this again. That's better. No. Cool. All right. So it's, as I said, rigged up with pre-release bits. So you won't have it, but I do. So now we have basically a blade for gateways, right? So if we go to this gateway blade, obviously there is nothing. So we're going to create one right here. So to create a gateway, give it a name. So we call it, Sputnik 1. That's our code name for this thing. Region, essentially, think of it as location, right? So we have regions in Azure that's similar here. You can say it's, in my, west headquarters or my data center in the east, whatever that is. So here I'm going to say it's my precious. That's the name of my computer. And I'm at demo at integrate, right? So now let me add this guy. So gateway is created. Obviously, it has 0 nodes connected. Everything is cool. So let's click on this guy and see what we have here. First of all, we've got 2 keys, right? So the secret keys, you can rotate them. These keys are used to generate credential that gateway will use to connect to this instance and authenticate itself, right? Simple. So we have this deployment tab here, right? What does it have? It basically have the machinery to generate access token. And it has a few deployment scripts. As you can see, the URL, the management URL is already in the script, for instance here. And obviously, same goes for Kubernetes. Somewhere here it should be written in, right? There is no token yet because we didn't generate one. So I'm going to just click a button to generate one. As you can see, it immediately substituted there. And so now, essentially, you can actually take a snippet of this, copy that text, or copy a YAML file if you want node port or you want ingress, and just apply it to your Kubernetes deployment. And voila, you're up and running with the self-hosted gateway. So I already have my YAML here. Let me quickly walk you through this. First, I'm creating a secret in Kubernetes to hold my credential. I have to paste it here, but it's there, right? I'm creating a deployment, and as you can see that I'm pulling from Microsoft Container Registry Gateway, in this case, latest. And I need to provide, through environment variables, 2 things, credential and connection string. Very easy, right? And we're pulling credential from the secret. And then I created a node port service to expose the thing, right? So it's essentially what you will have in the Azure portal when you copy it. So now we're going to attempt something here. So I'm going to take this guy, right, and replace it with a credential. Okay. And then I'm going to go and copy the URL to the management endpoint and put it in right here. Let's see if we're lucky. So now I'm going to just deploy this into my Minikube. All right, it says successfully applied. Let's go and check. So refresh, open default namespace. Yep, we have a Sputnik deployment, it's green. We've got running one replica as I requested. We have a pod with Sputnik, which runs our Sputnik container from the registry, right? It pulled it down. Everything is fine. Looks like everything is fine. All things look positive. And of course, I have a service for now for Sputnik as well with node port exposed here. I can actually get logs. And in these logs, as you can see, we are listening on localhost there. And as you can see, essentially what it did after starting, right, it quickly synchronized configuration. So it pulled configuration from the cloud. Not a lot to pull because there's no APIs. I'm going to show you that next. So at this point, what we have is, again, our API running on-prem on my desktop. We have now Gateway running in Kubernetes also on my desktop. Obviously, my desktop is not accessible to Azure. But now I need to wire things up. First of all, let's validate that we actually have an API running, gateway running here. So I'm going to curl. Before I curl, actually, let's just go and do one more thing here. I need to run this command to get a service URL for this node port. So I can use the one you remember. I have HTTP and HTTPS. So let me just do this. So let me curl this guy here. This is basically a base URL for the gateway, and obviously it's going to say, I can't find anything. But at least we know something is running there, right? So it's good. So now what we need to do is we need to configure an API for API management. For that, obviously, I'm going back to my instance here. And I'm doing this, right? I'm going to APIs. Before I actually do that, let me show you some products here. So products allow you to configure access to APIs. So I included my API into public product. Public product doesn't have keys, so it's easier to curl without a key. But keys would work, right? So just an optimization. So here, I'm going to go and create an API for HTTP bin. I wrote a little Swagger definition for it. Here we go. I'm going to call it HBO for httpbin.org. And then I'm going to put it into, oops, wrong. I'm going to put it into public, so we don't have to worry about the keys. Create. API has been created, which is nice, right? Now, the only thing we need to change here is the IP address, right? Or the web service URL. Here it's points to http.org. So I need to actually point it to my to the backend running on my machine. For that, I need to know IP address. So I think this one is the IP address I need. So again, this is IP address of my machine here. So I'm gonna basically stick in here, and everything looks good. All right. So now what happened is we have now API configured in API management. Obviously, as we can come here and look, we can pull logs again. And now you see a lot more stuff, right? And essentially the point of that stuff is that it discovered some things, some operations, some APIs, et cetera, some changes in API management, and it's pulling them down, right? So now our gateway actually is configured with API information I entered in the cloud, right? So at this point, we can actually try to curl it. So this one is base URL. So the name of my API is HBO, and we can try get command. Bam, right? You see, response, right? So what I'm doing now is from my machine through self-hosted federated gateway, I'm calling this HTTP bin API on my machine. Everything is local, right? Nothing is going through the cloud. However, configuration is coming from the cloud. So what about policies? Would policies work? Let's try. So if I go here into design, this policy to try is rate limit, right? I'm going to say 3 every 10 seconds, and I'm going to do by IP address for simplicity. Save, right? Go back. Let's try it. 1, 2, 3. Nice. All right. What would you expect, right? Works. So that essentially is the demo, right? So this thing is real. It actually works. It's robust. I tried it many times, deleted, restarted, pulled it back down. So we are in pretty good shape. So I hope, as I said, to make it available to you guys so you can actually start using it in pre-production later in summer, and let us know what works, what doesn't, and provide feedback. Now, if you want to be part of the private preview, which is coming up this end of this month, or want to provide feedback in a more detailed fashion and learn about the some of the design decisions we made here, et cetera, feel free to ping me, and we can schedule a call and do that. With that, let's go back to the slides. And of course, here's a link created by Mike over here. So he said, why do we have all these links, right? Why don't we create just one, which has all the information? And so now we have that one link, which we will keep up to date. And behind that, there is a page with all the useful information about API management, how to stay in touch, how to stay abreast of changes, and all the other good stuff. With that, we have another few minutes before the next session. So if you have any questions, I'll be happy to answer them, or we can just meet during lunch and later today. Thank you. Any questions? Unfortunately, I can't hear.
Hello?
Yeah.
Is it working in hybrid mode as well? So basically you can have an API on cloud and also in on-prem where
Yeah.
you're hosting? Yes.
Yeah, absolutely, yes.
Okay.
So what I didn't show you, and that's actually a very good question, what we didn't actually add yet, right, is, logically you would want to say, when you create an API, where is this API available? Is it available on the cloud? Is it available on this gateway or on that gateway? That we're going to add, right? So you essentially will be able to tell through API management which gateways should handle which APIs. And one instance, the whole point is should be able to handle with these guys, with gateways, any API anywhere. Yeah. Any other questions? Cool. Thank you.
Covey.co